This video is writing ionic formulas with transition metals. The transition metals are the elements in this part of the periodic table here, and ionic compounds that have transition metals in them usually have Roman numerals in the name, like this here. So in this video, we'll learn how to take a compound that has a transition metal in it and how to write a chemical formula for that. Now, if this stuff is totally new to you, you might want to get some background information from two of my videos. The first is called Writing Ionic Formulas Introduction, and the second is called Transition Metals in Ionic Compounds. If you're all set with the background, let's get started. Here's our first example, chromium 2 iodide. We want to write a formula for it. Now, when we're writing ionic formulas, the first thing we want to do is find out the charges of the ions in the compound. And we often do that by looking at where they are on the periodic table. So here we have chromium and iodide. Chromium, Cr here, is a transition metal. And transition metal ions can have a variety of charges. So you can't tell just by looking at the periodic table what the ionic charge is. So that's where this Roman numeral comes in. This Roman numeral here is the number 2. And it tells us that in this compound, chromium has a charge of +2. So that's chromium. Now we have iodide, which is what we call iodine when it has a charge. And iodine is in this column right here, which means that in an ionic compound, its charge is always -1. So now we want to add ions of one or both of the elements so that the charges balance. Okay? Here we have 2+ from chromium and we have 1- from iodide. So to get this to balance, we'll add one more iodide. So now we have 2+ here and 2- here. Now we write the formula. We have Cr. We have one of them, so we don't write anything after that. And then we have 2 of the iodides. So I do I2, and that is the formula. Now here is a misconception that I want you to be careful of. A lot of people see this 2 in Roman numerals, and they think that this means there should be 2 chromiums in the formula. Okay, that's not true. As you know, this Roman numeral 2 means that chromium has a 2+ charge. It's talking about the charge of the ion, not the number that you have. So be careful of that. Now let's write a formula for manganese 3 oxide. First thing we'll do is figure out the charges on the ions. So manganese here is a transition metal. Don't confuse manganese with magnesium, which is not a transition metal. So manganese is an element that can make many different ions. You can have Mn 2+, 3+, 4+, 6+, and 7+. So the Roman numeral 3 here is telling us that in this compound, manganese has a 3+ charge. Now oxide is what we call oxygen when it has a negative charge. Oxygen is in this column here, which means that in an ionic compound, it has a charge of 2-. So we got Mn 3+ and O 2-. We want to add one or more of these elements so that the charges cancel. Now when we have a 3 and a 2, there's a little strategy here that you might know. Here's how we do it. To get the charges to balance, we add another one of these manganese, and now we have 3+ and 3+, so we have a total of 6+ on this side. And to balance that with the oxides, we add another for 4-, and then we add another for 6-. 3 oxides balance out 2 manganese 3+. So our formula is Mn. We've got 2 of those, 2 O, 1, 2, 3 of those. And as before, don't be confused by this Roman numeral 3. The 3 does not refer to the number that should be after manganese in the formula. The 3 refers to the ionic charge on manganese. Let's do one more. Lead 4 nitrate. So this Roman numeral IV here is a Roman numeral for 4. Believe it or not, it's important to know the Roman numerals in order to deal with transition metals. So you want to make sure you learn these at least 1 through 7, which are the most common. Now, to write the formula for lead 4 nitrate, we'll figure out the charge of both of these ions. Lead, Pb here, isn't technically a transition metal, but lead is like the transition metals because it's able to make multiple ions with different charges. So that's why we use the Roman numerals anyway, to show what charge lead has in this compound. So we got lead 4, Pb 4+, and then we got nitrate. Now nitrate isn't on the periodic table because nitrate is a polyatomic ion. It's a big clump of atoms that together have a charge. So for this, we need to take a look at our list of polyatomic ions. How did I know that nitrate was a polyatomic ion? You just got to learn a list of the polyatomic ions. It's a pain, but you just kind of got to do it. Anyway, nitrate is right here, NO3, and that whole clump of atoms has a 1- charge. So now we want to add one or both of these to make the charges balance. We have 4+ from the lead, and we have 1- from the nitrate. So I add another one of these. Now I have 2-, now I have 3-, and now I have 4-. So my formula is going to be Pb, I have just one of those, and then I have 4 of these nitrates. And since this is a polyatomic ion, I'm going to use parentheses because I want to show that I have 4 of this whole clump. So I put NO3 in parentheses and then do 4 outside those parentheses. So keep in mind, again, this 4 refers to the charge of lead, not to the number that should be after it. And remember that since this is a polyatomic ion, we use these parentheses and then a number outside of it to show that we have 4 of this entire group of atoms. So that's how we write formulas for compounds that contain transition metals. In the next video, we'll learn how to go in the other direction. How to start with a formula that contains a transition metal and then write a name for it. This is a little bit more challenging because transition metals don't always have the same charge. So we have to do some math and figure out what the charge of the ion is, and then we use that to write the name. So check out that video called Naming Compounds with Transition Metals.